All right, you're about to see 6 cards. So the way that this worked is you were supposed to match up the vocab terms, the examples, and the definitions. So if you look at proportional relationship, that is when a graph goes through the origin. So I would drag this here, and you can see it highlight. And now those are together because they are a match. And this is a graph going through the origin, so that's the example. So these things were meant to be a match, and then the unit rate is a comparison of y to 1 unit of x, and an example of that would be 60 miles to 1 hour. And you can see that right here on the next screen. The answer key, again, those 3 things go together, and these 3 things go together. So on the next slides, you're supposed to fill in the missing information and also the unit rate. So you've got an equation y equals 10. So y equals 10x. I can plug in any number for x. I always like to use 0 because I think that's just the easiest number to do any type of math with. And so if I have y equals 10x, what that means is I'd rewrite that equation, and of course we're substituting 0 for x. So 10 times 0, like I said, it's pretty easy to do the math there. That would mean that y has to equal 0. And so I'd write the cost as 0, which makes sense. If you're not spending any time on the phone, you shouldn't pay any money. Although, I guess nowadays it doesn't make sense. But just go with me, all right? 1 hour, if I have y equals 10x again, it would be y equals 10 times 1, and 10 times 1 is just 10. And I think the easiest thing to do is just to change the hours by 1 each time. You could say different numbers here. You don't have to say them in order, but this is probably the easiest way. So it's $20 for 2 hours and 30 for 3. So I would plug in those numbers in the table here, obviously. And then as far as what the unit rate is, the unit rate, as we said on slide 3, it's a comparison of y to 1 unit of x. So 1 unit of x, remember, is $10. So I would say the unit rate is $10 per hour, something like that. Right here, we're given 2 hours and $5. We're just giving an ordered pair, but they do tell us it's a proportional relationship. And by the way, the last one was also a proportional relationship. And if I borrow my table on the other side, anything that goes to the origin, which is 0 for x, 0 for y, is a proportional relationship. So that's happening as well on this one here. So they just gave me an ordered pair when they did that. So I'm going to fill in the rest of the table here. And I can fill in any numbers, but I do think in general 1 is a good number to use. And in this particular instance, it looks like if I take the hours and divide them by 2, I'd also have to take the cost and divide it by 2, right? Because I want to prove, if it's a proportional relationship, that whatever I'm doing to x, I have to do the same thing consistently to get y. So if I take 2 hours, I'm multiplying it by something to get 5. And that number would have to be 2.5. 2 times 2.5 is 5. So 1 hour is $2.50 or $2.50. And then I could make up any number for this. So I'm just going to have some fun and put 10 hours. And if I do 10 hours, well, I just multiplied these 2 hours by 5. So I'd have to multiply this cost by 5. Or you could choose to see it as, if I multiply the hours by 10 here, I have to multiply the cost by 10 here. Or, again, if you just go straight across, 10 hours times $2.5 equals $25. So the unit rate in this instance is $2.50. Let me do the dollar sign. $2.50 per 1 hour. And what equation describes this situation? In other words, how do I get from hours to dollars? I've been saying it throughout. And let me go to the table here. So I really think using your notebook is going to be vital as far as showing this. When you think about the equation, you want to be consistent. How do you get from 0 to 0? How do you get from 2 to 5? How do you get from 1 to 2.5? This is probably the easiest one to start with. We're going to be multiplying 1 by 2.5 to get 2.5. And of course, 0 times anything is going to equal 0. So I can still do times 2.5 there. And you just want to prove that that works all the time, and it does. So if you take x right here, every time I'm multiplying x by 2.5. And if you multiply x by 2.5, x times 2.5 is going to give you y. So looking at the options here, I would choose this one, y equals 2.5 times x. And it makes sense with the table. Last one here, the bill for guitar lessons was $75, so that's a cost. I could put that over here. And the lesson lasted 3 hours, so I can put that here. That's an ordered pair. You can imagine if it was a 0-hour lesson, it just makes sense to pay $0 for that. And then 1 hour, well, again, if I'm doing 3 hours and $75, I want to be consistent in what I multiply both of these by. 3 times 25 is 75. So you'd want to do 1 times 25, and then maybe 2 and 50, or if you wanted to put 4 hours and 100 in here, it wouldn't be wrong. You can put a variety of answers. Just make sure that you're multiplying by 25. And the unit rate, of course, is $25 per hour. And it looks like I forgot to write in a space for you to put the equation. But the equation would just be, all right, you have x equals y. That doesn't make sense because it's only true right here. So 3 doesn't equal 75, so what do I have to do to 3? I have to multiply it by 25. 3 is x, so I'm going to put 25 times x equals y. That would be the equation. Again, this is a proportional relationship because you can see it goes through 0, 0. And speaking of proportional relationships, the last slide, it says, look at the graph below. And it's looking at the 3 different examples you just did. So this one in green right here that's very, very steep, that represents what you just looked at here. The one that's in red, it's the second steepest, the one kind of in the middle. That's related to this equation, y equals 10x. And then the other one is y equals 2.5x. So all 3 of these equations, if you look at them, it's sort of tough to see, but they're going through the origin. And we showed that also in the table that they're going through the origin. You can see it there and there. You can see it here and here. And you can see it here and here. They're all going through the origin. So based on that, I would say all of these are proportional. So we want to check off all 3.